This is a video for Systems of Linear Equations module. In this video we're looking at section Syle F. To begin, let's look at graphing linear lines. Now, a linear equation of two variables can be represented graphically as a straight line. Now, to graph a linear equation, it is necessary to determine at least 2 points that lie on it. To find a point on a line, all we do is pick a value for one of the variables. It can be any value. X is 10, X is 12, X is 1, it doesn't really matter. We substitute that value into the equation and then we solve it to determine the value of the other variable. There are two methods for graphing a linear equation. The first is a table of values where we choose 3 points, and this is useful for equations in the form y equals mx plus b. So that's our gradient intercept form, where m equals a gradient and b equals a y-intercept. The other option is to find axial intercepts. Now, axial intercepts, we have our axes like this and our line. We're finding the points where that line cuts the axes. So here is where it cuts the x-axis and here is where it cuts the y-axis. This method's useful when our equations are in the form of ax plus by equals c, so their x's and y's are on one side. So let's look at some examples. The first one, using a table of values, graph the following lines by first determining 3 points that lie on each of the lines. So for y equals 2x minus 1, again it doesn't matter what I choose for the values of x. 0 is always a good option though, because that means x gets eliminated. In this case I'll just use 1 and 2, because they're nice and easy to substitute in. So now I've got y equals 2 times x, so 2 times x is 0, minus 1, so that's 0 minus 1 is minus 1. So I've got 0, negative 1. Next one, y equals 2 times x is 1, minus 1, 2 times 1, 2 minus 1, which is 1. So the point 1, 1. And last, y equals 2 times x is 2, minus 1, so it's 4 minus 1, which is 3. So putting those points on our axes, remembering that x-axis is always the horizontal axis, you can see that labelled, and the y-axis is always the vertical axis. So when x is 0, y is negative 1. Got that point. When x is 1, y is 1. And when x is 2, y is 3. So I've just put those 3 ordered pairs on my graph. I then use a ruler to join the 3 points. We put an arrow on either end of the line, meaning that that line continues beyond the axes that I've drawn. And we label the line with the equation. It is advisable to use pencil when sketching, so then if you make a mistake you can easily rub it out. The next equation we've got is y equals negative a third x plus 4. Now this negative third is going to make me pick certain points for x. I always pick 0, as I've already said, but for my other values I'm going to pick multiples of 3. The reason being, when I multiply x by negative a third, I'm going to get a whole number, so it makes it nice and easy. So here we've got y equals negative a third times x, which is 0, plus 4. So that's 0 plus 4 is 4. So my first value is 0, 4. Next, y equals negative a third times 3 plus 4. Negative a third times 3 is negative 1 plus 4, which is 3. Now, if you're not very good at fractions, you can plug them on your calculator. Just remember, this 3 is like 3 over 1. 3 into 3 is 1. 3 into 3 is 1. So you've got negative 1 times 1 is negative 1. Next one, y equals negative a third times 6 plus 4. Again, 3 into 3 is 1. 3 into 6 is 2. So you've got negative 1 times 2 is negative 2 plus 4, which is 2. So the point 6, 2. Sketching these, 0, 4, x is 0, y is 4, 3, 3, x is 3, y is 3, 6, 2, x is 6, y is 2. And then I just join my 3 points. excuse the line that went across then. It's a bit hard to draw a line on the computer. Okay, so not extremely accurate because I am drawing it on the computer, but you get the idea. Now let's look at how to sketch using axial intercepts. Now axial intercepts are where the line cuts the x and y axis. So for the x-axis, which is here, we know that everywhere on that axis has a value of y equals 0. And for the y-axis, which is here, every point on that has x is 0. So we're going to use these 2 points. So for 2x minus y equals 1, we let x equal 0. So now we've got 2 times x, which is 0, minus y equals 1. So 2 times 0 is 0, so I've got negative y equals 1. So therefore y equals negative 1. So my first point is 0, negative 1. Next, y is 0. So 2x minus y, which is minus 0, equals 1. So 2x equals 1. 2 lots of x is 1. Divide both sides by 2 to get rid of that 2, and you get x is a half. So my other point is a half, 0. I now put those points on my axes. So I've got 0, negative 1, and a half, 0. Now you could have drawn your axes so that your x-axis went up by halves, which would have made it easier to sketch. And then I put the arrows on either end, and I label my line. Okay. Here's another one. Now you might want to pause this video and give it a go yourself. Okay, and then replay it once you've solved it and see if you're right. So if x is 0, we've got 3 times 0 plus 4y equals 12. So 4y is 12. Y is being multiplied by 4, so we divide both sides by 4. We get y is 3. So that's the point, 0, 3. Next one, y is 0. 3x plus 4 times 0 equals 12. 3x equals 12. X is 4. Because x is being multiplied by 3, we divide both sides by 3. So I've got 4, 0. Putting these points on my line, I have 0, 3 and 4, 0. And then I just join the dots. Again, put an arrow on the end of each line and label. You're done. Remember to always label your axes with your variables. Now, the graphical solution of a system of linear equations isn't much harder. Okay? All we need to do is find the intersection point of 2 lines representing each of the equations. So instead of just sketching one line, we're going to sketch 2 lines. And the solution is the ordered pair, or the coordinates, of the intersection point. Therefore, to find the solution of a system of linear equations, you simply graph each line on the same set of axes, and where the lines intersect is a solution. Now remember, the solution is only as accurate as your graphs are, so it is important to take care when drawing your axes and to use a ruler. So for this one, use graphical techniques to determine the solution of the system y equals 8 minus x and 2x minus 3y equals 6. Now my first equation is in the form of y equals mx plus b, so I'm going to find 3 points and graph that one. My second equation is in the form of ax plus by equals c, so therefore I'm going to use my axial intercepts. It doesn't really matter which method you can use them for either. So for the first one, y equals 8 minus x, I'm going to use x is 0, x is 1, x is 2. So I have y equals 8 minus x, so 8 minus 0 is 8. So that's 0, 8. My next one, y equals 8 minus x, which is 1, which is 7. And my next, y equals 8 minus x, which is 2, which is 6. So 2, 6. Then I can sketch this point, so 0, 8, 1, 7, 2, 6. Now because we are going to be trying to find a solution, it is advisable to be as accurate as possible. I'm not going to be able to achieve that as well as what you will. And I also need to label the line because I'm putting more than one on it as well. Now for the next one, 2x minus 3y equals 6. The y-intercept is when x is 0. So I have 2 times 0 minus 3y equals 6. Minus 3y equals 6. Divide both sides by the negative 3 and I get y is negative 2. So 0, negative 2. X-intercept is when y is 0. So 2x minus 3 times 0 equals 6. 2x equals 6. Divide both sides by 2. You get x is 3. So 3, 0. Put this on. So 0, negative 2. 3, 0. And then carefully join the dots. Okay. Label my line. You don't need to do them in different colours, I've just done that so you can see what I'm doing. Now my intersection point is there. Mine isn't as accurate as probably could be, but you can read off there that that point is 6, 2. So my solution is x equals 6, y equals 2, or as in a coordinate 6, 2. What do you need to do now? Well, you need to practice. And in the textbook under Syle F1, there are 5 questions that you can do to solve using graphical methods. If you have any questions, remember to ask the course coordinator.